Hello, we'll be seeing how to get the conditional coverage of a smart contract. So, this is a sample smart contract that we have. Um, the name of the contract is test, and we have various functions such as push one, pop one, toggle, plus 5, and so on. So, each function each function in this smart contract has conditions such as, for example, this pop1 function has a condition that if the add array dot length is greater than 0, then do operation. So our purpose here is to determine the conditional coverage of our sample smart contract using the techniques that we have developed. So for example, we'll see uh, if this condition is true as well as false with the transaction inputs that we give from a fuzzer. So now let's have a look. And now what we will be doing is, for each condition that we find in a smart contract that we are testing, we will be inserting assert statements to ascertain whether both the branches of that condition are being executed. So we'll be, for example, if we have a condition if a, so now we'll be checking if this condition is true as well as false. So we'll be checking if this assert is being called and this assert is being called. So assert not a will tell us if the condition is ever true, and the second assert will tell us if the condition while real-time execution is ever false. So this will help us determine the conditional coverage of the smart contract. Now what we'll be doing is we'll be injecting or inserting these assertions in different files. So when we are iterating through the smart contract, we find the first condition. Now what we'll do is we'll create two different files, where once this condition is assert this condition being true, and the second is assert this condition being false. So and hence when these assert conditions are being called, we'll know that okay, this condition has been executed in its true form or the false form or both forms. So for this we'll be using the assertion injector that we have built. In the assertion injector we have like we take the input and then we insert assertions in all the parts where we have a condition. So for example, if we find n different conditions in a smart contract, there will be 2n different insertions to assert. For each condition we assert a true assertion and a false assertion, like not a and not a. So after that, this is the file which is responsible for doing that. Now before asserting injections, we'll also be removing any type of comments which are present in our file. So this is a small code which removes any stray lines or comments from our smart contract. Now we've got this. So now we'll also be using this script to execute our smart contract. So in this script we take the take a command line argument, which is the name of the smart contract, and we perform sanitization and all, and after that we check whether we run the smart contract, like each smart contract that we have got, against some random fuzzy inputs using a fuzzer named echidna. So this will give us how many smart contracts have an assertion which failed, which tells us the conditional coverage. So let me show you by executing. So let's say we execute our script, and the name of the smart contract was just len. So just len. So now you will see that it has started execution and it is executing tests. Now you can also see, like, while this is being done in the background, I'll show you that for each just len dot sol smart contract, we have generated a total of 22 files for each. Like 1 1 and 1 2 would show that for the first condition that we found, we have got two different files. So let's see what these files contain. I'll open both 1 1 and 1 2. So as you can see, we have this function where we found our first condition. So our first condition was add array.length greater than 0. Now you will see that we have inserted an assert here in the 1 2 file and as well as the 1 1 file. So in the 1 1 file we have done not like complement of the condition, and in 1 2 file we have done complement of the condition. So 1 1 file is responsible for, now when will this assert be invoked or executed? When this condition is true, which will become as complement and become false, and this assert will be called. So we know that if this assert statement fails, then the true branch of this condition is being called. And if this assert statement fails, so that means if this is, let's suppose this is false, then its complement will become true, and again its complement, it will become false. So if this assert statement is false, we need that the false branch of this condition is being executed. So we can take a similar example in, let's say, 4.1 and 4.2. So as you can see, we have asserted the condition we found in the for example. So here this in the for condition, so this and this. So let's see where our execution is at. So we have executed tests for 14 files till now. Now I'll show you the execution. So each file, when they execute, we can see what the fuzzer generated. So for example, our 1 1 file, we see that the assertion in this file has failed. Similarly, 1 2, the assertion has failed, and you'll see, we see whether assertion like this assertion has failed, or we have for example in the 2 2 file, we have all there have been no assertion failures in this file. So we can say that that particular condition that we have in 2 2, it is not being reached. So like we are not getting, like that condition is not getting covered. So like here it has failed in we can see in which function it has failed, and we can see which file it is and whether it has failed or all have passed. So assertions in all have passed and so on. Now let's see where our execution. So we have executed like only 2 more files are remaining in our execution, and like you can see we have total 22 different files that had been created. So now you see we now are executing the tests on the last file that we have. Yeah, so we have from 1 1 till 11 2 we have files, and so now as we see that our job is done, and there were total 22 assertions in the smart contract that we inserted, and a total of 12 assertions have failed. So we can safely say that with our current test, we have gotten a conditional coverage of 12 out of 22. Now, one more thing is we are using a fuzzer for executing these tests on the files. So, if we increase the strength of the fuzzer, the we are more likely to find better conditional coverage, but it will take longer time than it takes normally. So here is the part, here is the configuration that we give to the fuzzer. So if you increase the test limit and the shrink limit, let's say we do test limit as 25,000, shrink limit as 5,000, then we'll get a much better coverage, but it will take a little like longer than it took this time. So for example, instead of test limit 25,000, we do it like 50 1,50,000. It will take more time basically. So okay, and now I'll also show that after all this execution, first of all I showed you the execution.txt file that we are generating. So for each test it is showing like for which functions it is always passing and all. Now we'll also see that we have if we want to see that which assertions have failed and which assertions have not failed, you can check the results.txt file. We show how many assertions were there, how many have failed, and we also show that assertions in which all files have failed. So for example, we know that in 1, 1, 1, 2, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 6, 2, 7, 1, 7, 2, 8, 2, 10, 2. In all these files, assertions have failed. So these, for example, we see that assertion is just in Jocelyn mod 6.1 has failed. So we can go to 6.1 and we can check the assert statement that it has. So it has this assert statement. So now we can say that this assert statement is being executed. That means this condition is becoming true and this branch is being reached. So this condition is being covered. Now we can also see the visually we can see which all coverage we got. So we get a coverage information in the corpus directory. So for example, if you see for this is for the one file. So smart contract Jocelyn mod 1.1. Now if you see, if we star is all the star, it visually shows all the parts of the code that the fuzzer reached, and star e shows that here we got an error. So this assert had failed. So you can see star e we get against this function and this statement. So this is where an assertion failed. Similarly, let's say if we check this file, so Jocelyn mod 5.2, if you remember, like I'll show you the results as well, 5.2 hadn't failed. So in 5.2 we don't get star e anywhere. We can see that all the places where we see a star are the places where it reached. For example, it reached all these functions and all these conditions, but we never got an error. So we only see star, which shows the statement coverage, but not if we had gotten a failed assertion, that would have mean we have gotten conditional coverage. So let's see, for example, let's say 6.1. So in 6.1 you can see, if you remember from our results, 6.1 had failed. So if you see 6.1, you can see that star shows which all statements it reached during the testing, and you can see this function, this assert statement had failed. So in this function star, you can see star e. So you can also see using this visual information, or you can follow the textual result that we have generated. So yeah, so I think that's all. Thank you.